Picture this. It's 2 a.m. Your SSH directly into a headless Linux production server. The core API is failing, error alerts are just firing off everywhere, and yeah, customers are noticing. You've got no graphical user interface, no web browser, and you certainly don't have Postman or any other visual API testing tool. So you need to diagnose the problem immediately, right from the terminal. What do? Well, you reach for your ultimate diagnostic weapon. Welcome to this explainer where we're going to master the single most important command line tool in an IT support engineer's arsenal. We'll even spin up a demo against the recres.in test API so we can see the whole shebang in action.
That weapon is curl. As its creator, Daniel Stenberg, actually points out, curl is the internet transfer engine for countless software applications in over 20 billion installations. 20 billion! That number is just absolutely staggering. Under the hood, its libcurl library is running in cars, television sets, routers, medical devices, and even gaming consoles. But for us, the IT support engineers, the command line interface of curl is the true star. Because it's available by default on almost every operating system and server on the planet, it serves as your ubiquitous, go-to, headless diagnostic tool. It doesn't need a UI, which makes it absolutely perfect for untangling those really complex network knots directly from the shell.
Here's our roadmap for today's explainer. First, mastering GET and POST requests. Second, authenticating with bearer tokens. Third, verbose mode and JSON formatting. And finally, a real-world production server support scenario.
Okay, let's jump straight into Section 1, Mastering GET and POST requests.
So when an endpoint is totally unresponsive, you usually don't need the entire HTML or JSON payload just to know if the server is actually alive, right? By using a basic GET request combined with the capital I flag, say against the request.in/API/users endpoint, you're commanding curl to fetch only the HTTP headers. It's an incredibly fast way to just ping a web service. Instead of downloading megabytes of data, it discards the body and gets straight to the point. It shows you the HTTP status code, verifies cache headers, and confirms the server software. It's really your first, fastest check to see if anyone is actually home.
Now, transitioning from retrieving data to sending it requires a bit of a shift. For a POST request to an endpoint like recres.in/API/users, we use the -x post flag to explicitly declare the method. And because modern APIs expect JSON, we use the -h flag to set the content type to application/JSON. Finally, we pass the actual JSON payload directly using the -d or data flag. This perfectly simulates a form submission or an application data push entirely from the command line. Pretty neat, right?
Moving right along to Section 2, Authenticating with bearer tokens.
We all know modern infrastructure isn't just open to the public. It requires strict authentication, and we need to handle that gracefully right from the terminal. The crucial point here is knowing how to prove who you are without relying on some interactive login prompt. And this is exactly where bearer tokens come into play. Passing a bearer token in curl simply requires adding another -h flag to inject a custom authorization header. We just pass the string authorization bearer followed by the token itself. This approach is highly secure, it keeps your automated scripts running without manual intervention, and honestly, it's the absolute standard for interacting with REST APIs today.
All right, on to Section 3, Verbose mode and JSON formatting.
Now, curl is famously a talkative tool, and that is exactly why senior engineers love it so much. Interestingly, modern versions actually feature a tiered verbosity system. Level 1, triggered by a single -v, shows you basic headers and connection status. But it turns out if you're chasing down a really complex protocol-level anomaly, stacking 3 Vs plunges you deep, into tracing protocol content and SSL negotiation frames. You can literally watch the cryptographic handshakes happen in real time. When you turn on verbose mode, your terminal is going to flood with text. It's a lot. So, to filter this noise effectively, you really need to understand curl's specific prefix system. Lines starting with an asterisk, well, those are internal informational messages from curl itself. Things like DNS IP resolution or connection state changes. Lines starting with a greater than symbol represent the raw metadata your client is sending to the server, and lines with a less than symbol denote the headers you are receiving back. By tracking these specific prefixes, you can instantly spot exactly where the communication breaks down. Let's actually zoom in on those asterisk lines to see this in action. If you're dealing with an older server or maybe some really strict enterprise firewalls, you might encounter an SSL connect error, specifically error 35. Verbose mode acts like an absolute X-ray here. It exposes the exact TLS version and cipher suite being negotiated.
If there's a mismatch between your local environment and the production server, verbose mode is going to catch it right here in the handshake lines, long before any application data is ever transmitted.
In today's API landscape, JSON is everything. But the thing is, APIs are designed for agents and machines, not human eyes, which often results in just a massive, unformatted blob of text. Gross, right? Well, by simply adding a pipe and the JQ utility to the very end of your curl command, it instantly transforms that chaotic wall of text into beautifully structured, color-coded, human-readable data. It is an absolute game changer for verifying API outputs on the fly.
Which brings us to Section 4, Production Server Support Scenario.
Let's put it all together. Here is the exact systematic workflow a senior engineer relies on when diagnosing a live production incident. Step 1. SSH into the server to ensure you're testing from the exact network environment experiencing the issue. Step 2. Construct an authenticated post request aimed at our recres.in endpoint. Step 3. Pipe the output to JQ for immediate visual verification of the response. And Step 4. Carefully verify the HTTP status code.
So here is that ultimate combined command. We have -v for verbosity, -x post for the method, our bearer token safely stored as an environment variable, our content type header, and of course we pipe the whole thing to JQ. But notice the syntax for the payload, -d @data.json. Using the symbol tells curl to securely read a file-based payload. This solves so many problems, you guys. It prevents frustrating shell-specific escaping errors with quotation marks, it keeps sensitive JSON data completely out of your terminal's process list, and it perfectly supports documentation as code workflows.
Now look, even with the absolute perfect command, network failures are inevitable. When they happen, troubleshooting begins with the numerical exit code curl returns. These codes point directly to the specific layer of the OSI model where the failure actually occurred. Code 6 means couldn't resolve host, so a DNS failure. Code 7 is couldn't connect, meaning the server's online but the connection is refused, which is likely a closed port. And code 28 is an operation timeout, often caused by severe server-side lag. Decoding these exit numbers just gives you an instant diagnosis.
So let's go back to that 2 a.m. scenario. The alerts are firing, Postman isn't there, you are SSH'd right into a blank terminal. But now you aren't flying blind. You know exactly how to ping headers, inject secure tokens, send structured file payloads, and X-ray the TLS handshake. You literally hold the ultimate IT Swiss Army knife. So the only question left is, what invisible network anomalies will you uncover with your newly refined command line skills on your very next support ticket? Thanks for joining me on this explainer, and hey, happy troubleshooting.